In this video, we're going to look at how we can combine scalars and vectors. Remember, a scalar is a quantity with magnitude only, compared to our vectors, which have a magnitude and a direction. Now, we can't add scalars and vectors because they're not the same type of thing. But what we can do is what's called scalar multiplication. And what that means is if we have a vector, A here, we can create a new vector which is a multiple of that vector. So it has to be in the same direction, but it can be a multiple of the magnitude. So we could do one that's in the same direction but twice as long, and that one would be called 2a. In a similar way, we already know, because we've seen, we can do negatives, which are an example of a multiplication by a scalar. We can have minus a, that's multiplying by minus 1. Or we could do even further and combine these two, and we could have one that was minus 2a going in that direction there. And what we can notice is if we look at the column vectors of our vectors, then a here is 3 across and 1 up, so it's 3 and 1. If we look at 2a, our column vector goes 6 across and 2 up. If we look at minus a, our column vector is minus 3 because it's 3 left, minus 1 because it's down. And if we look at our final vector, it goes minus 6 across and minus 2 down. And what you should notice here is that for our original vector, if we were to want to do 3a, for example, we just do 3 times by our original vector. So we do 3 times 3, which gives us 9. And then we do 3 times 1, which gives us 3. So if we want a scalar multiple of a vector, all we do is multiply the scalar by each of the components of our column vector. To put that a bit more formally, if we have P is our scalar is equal to AB, and K is a scalar constant, it could be positive or negative, then K times P is equal to the column vector KA, KB. We multiply the scalar by each of the components of our column vector. And that's all there is to scalar multiplication.